Okay, continue with example 2 of the 7A notes. Again, we're going to solve this using the square root property. So this is set up very easily for us where remember we need to isolate our squared term, and it is, and then we're going to take the square root of both sides. And square root of this would be n minus 2. We'll get plus or minus, remember to remember that, the square root of 12, which will simplify into 2 radical 3. So we'll simplify that. Then to finish up, we just need to move our 2 over, and we'll have n is equal to 2 plus or minus 2 radical 3. So again, that gives us two answers. So one of our answers is going to be 2 plus 2 radical 3, and our other answer is going to be 2 minus 2 radical 3. So you need to ask yourself, can I simplify this? And the answer is no, because these are not like terms. We'd have to do this first before adding that. So our answers are here. So give a try at C. So pause it, try it. Remember, we want to do it before we forget how to do it, and then move on to the next one. So G, we have here, I need to isolate my squared term. So that means I need to, since 3 is multiplied here, I'm going to divide it. So I will have 4a minus 5 squared is negative 12 divided by 3, which is negative 4. Then I will take the square root of both sides. So square root, and that's going to give me 4a minus 5. And then the square root of negative 4 is 2i. So you notice we're getting all kinds of answers now, not just simple little 5s and 6s. We're getting all kinds of answers, imaginary radical answers, and so on. So now I need to, oh, and what did I forget? Yes, you're right. I forgot that plus or minus. So I need to put the plus or minus there. All right, so now I want to finish. I need to solve for a. So the first thing I want to do is move my 5 over. So 4a is going to be equal to 5 plus or minus 2i. And then I'm going to divide both sides by 4. So my 4's cancel. And I get that a is equal to 5 plus or minus 2i over 4. I can separate that into complex form, or I can leave it like this. Remember, if we leave it, we've got to look for a number that goes into all 3 of these to see if it reduces. So my answer then, I have 2 of them, 5 plus 2i over 4 and 5 minus 2i over 4. All right, so try H, pause it, and then come back and check again. All right, so now we're going to be solving by completing the square. So not all trinomial equations can be solved by the factoring method, where we move everything over, get a 0, and then factor. Not everything factors. So if we could rewrite the trinomial so that it looks like the problems that we had in example 2, well, here, example 2, if we could make it look something like this or that, then we could use the square root property. And that's what we're going to do. So, so let's take a look. Perfect square trinomials are trinomials that look like this. When I factor them, two numbers that multiply to be 9 and add to be 6 would be both 3s. It factors to be x plus 3 times x plus 3, so x plus 3 squared. Same thing here. This is going to factor to be x minus 6 squared. This little nasty fraction actually cancels to be x plus, or factors to be x plus 6/7 squared. So what we want to notice, what's true about all these that have this nice factoring where they factor to be squares, what's true about them is that if I take this middle coefficient and divide it by 2, so 6 divided by 2 is 3, and square it, 3 squared is 9. Negative 12 divided by 2 is negative 6, and negative 6 squared is 36. 12/7 divided by 2 would be 6/7. And when I square 6/7, I get 36/49. So you can see that they all have a pattern where if I divide the middle coefficient by 2 and then square it for that last one, I get this nice factorable trinomial that looks like this. So notice that in perfect squared trinomials, the constant term is half the middle coefficient, and then it's going to be squared. All right, so now example 3 is going to say find the constant term that will make each trinomial a perfect square, and then re-express it as a binomial squared. All right, so to make this a perfect square, I want to divide this by 2. So that gives me -10, and -10 squared is 100. So when I factor it, this is going to be an x. I'm going to do the square root of that, which is the 10, and this sign right there, so it's going to be minus. So that's x minus 10 squared. Half of 8 is 4. 4 squared is 16. So my a is going to go first. The square root of 16 is 4. 4 times 4 is 16. And this sign is going to go here, so that's a plus. And you see my little square up there. Half of 2/3 is 1/3. And 1/3 times 1/3 is 1/9. And then what goes in here is going to be y plus 1/3 squared. Over here, what's half of 1/5? Well, to do that, we might need to write it down. So half of, remember, of is multiply. Half of 1/5 is 1/10. And 1/10 times 1/10 is 100. And then this would be m. What's the sign that's going to go there? Yeah, it's minus. And then 1/10. All right, so now I'll run through those. So you give practice 1 through 4 a try, and we'll check those tomorrow. So stop, and then we'll go back to video 2 when you're finished with the video 3